Good morning, students. Okay, let us start analysis of Bullcat 3, Quant and AR section. Okay, Abhishek. Okay. I'm explaining question number 1. In how many ways 1500 can be written as a product of three integers? See, what was the keyword here? Integers. What do you mean by integers? 0, plus minus 1, plus minus 2, and so on up to. I mean the complete numbers where fractions are not allowed, decimals are not allowed. We'll take 0, all the positive numbers and all the negative numbers. So it says in how many ways 1500 can be written as product of three integers. See, suppose if I take 1500 can be written as the prime factorization I'm writing. It will be 2 square into 3 into 5 cube. That is the prime factorization for 1500. Now we want to write 1500 as product of three integers such that, suppose my integers are say 2a1 into 3 raised to power b1 into 5 raised to power c1. Similarly, 2 raised to power a2, 3 raised to power b2, and 5 raised to power c2. Similarly, let my third integer be 2 raised to power a3, 3 raised to power b3, 5 raised to power c3. Now the product should be 1500 in this case. So we can see that 2's total power should be 2. I mean a1 plus a2 plus a3, that should be equal to 2. Similarly, b1 plus b2 plus b3, that should be equal to 1, and c1 plus c2 plus c3, this will be equal to 3. So we are looking for the solutions of these many equations. We have done this formula in the previous papers too. What was the formula? N plus k minus 1 ck minus 1. I mean solution for this is 2 plus 3 minus 1 c3 minus 1. Similarly, this is 1 plus 3 minus 1 c3 minus 1. Similarly, 3 plus 3 minus 1 c3 minus 1. So how many solutions are possible? We can say for this equation, how many solutions are possible? They are 4c2. What is 4c2? 4c2 is nothing but 4 into 3 by 2. That is 6. For this equation, it will be 3c2, 3. For this equation, it will be 5c2. What is 5c2? This is 10. So how many in total solutions are possible? They are 180. They are 180. But we are considering ordered pair in this as well. I mean, suppose I am taking 4 into 3 into 125. That is one of the solution. But in this process, we have done, in this process, 4 into 3 into 125 is considered. 4 into 125 into 3 is also considered. So we have to remove all those cases where order matters. See, what is my question? In how many ways 1500 can be written as product of three integers? Now in this case, we are getting order as well. 4 into 3 into 125, that will result in 6 more cases which we cannot take. So we have to neutralize that. So see, now I'm taking those 1800 cases we have calculated. In those 1800 cases, just a second. 180 cases I got. Now 1500 is not a perfect cube. That's why 1500 cannot be written as product of three integers where all the three integers are same, because 1500 is not a perfect cube. But there are numerous cases as 1 into 1 into 1500. Are you getting me, guys? 2 into 2 into the remaining thing. Then we have 10 into 10 into the remaining thing. Then we have 5 into 5 into the remaining thing. These are four cases in which two integers are same. Two numbers are same. Each number, each case will result into three cases. 1 into 1 into 1500 can be written as 1 into 1500 into 1, 1500 into 1 into 1. That's why each case will result into three more cases. So there are 12 cases. I want to subtract these 12 from 180. Now 180 minus 12 is nothing but 168. Now these 168 cases are those in which all the integers are distinct. They are distinct. Now 168 cases I am getting in which all the integers, all the numbers are positive as well as distinct. For example, 1500 can be written as, say, we can write it as 1 into, say, 100 into 15, where all the digits are, all the numbers are distinct. Can he say all, for example, I'm taking this case will result in 6 more cases. 6 more cases. Arrangement of this. For example, 1 into 15 into 100, 100 into 15 into 1, 100 into 1 into 15. So these many cases are there. 2 more cases we are left with, 15 into 100 into 1 and 15 into 1 into 100. So every case is giving us 6 more cases. We got 168 case. We are getting 6 more cases. 1 is equivalent to 6 cases. So it will be nothing but 28 cases. Now we are left with 28 cases in which all the numbers are distinct as well as order does not matter. If I consider 1 into 15 into 100, 15 into 100 into 1 is already included in this case. Will not count it twice. So we are getting 28 cases. 1 into 15 into 100, I'm considering once again. See, what was the keyword here? Integers. What do you mean by integers? All the positive numbers as well as all the negative numbers I have to include. So one case is this 1, 15, 100 in which all the numbers are positive. I can consider this as well. I can consider this as well. And this as well. So from these 28 cases, I am getting 4 cases. 3 more, 4 cases in total. So what is this? 28 into 4 I am getting. So these many cases are possible. Now we had 4 cases in which 2 numbers were equal. From this case, I can get these many cases. So 3 cases from this into 4, because we were having 4 cases in which 2 numbers were same. So what is the answer in this case? 3 into 4 plus 28 into 4. That is the answer in this case. It will be 124, I think. That will be the answer. It was a very difficult question. Okay, any problem in this? Are you getting me, guys? Yes, all of you? Should I proceed further? Okay. Please go through second question as well. Second and 35th. I'm giving you 30 seconds to read this question. Yes, guys. Question number 2 and 35. Aman, you have written, please explain A1 plus A2 plus A3 again. That is a formula. Let me write formula first of all. Very important formula. It's a derivation of permutation and combination. That is number of positive integral solutions of the equation, say x1 plus x2 plus so on up to xk is equal to n. How many solutions are possible? N plus k minus 1, ck minus 1. See, I'm not going into derivation. I'm telling you the formula only. N plus k minus 1, c k minus 1. Very, very important formula. See, what is the keyword here? Positive. Sorry, it should be non-negative integral solution. Non-negative. 0 is also included. Non-negative integral solutions. Is it okay, Aman, now? I was using this formula. Okay. Let us see the second question. In how many ways 6 different books can be distributed among A, B and C such that A and B gets at least one book? Very good question it was. See, what is the keyword here? Different books. Suppose the question says in how many ways 6 similar books can be distributed among these 3 persons, then we can apply the same formula we were discussing, N plus K minus 1, Ck minus 1. But in this case we cannot, because books are different as well as persons are different. See, it says A plus B plus C, that should be equal to 60. Where A is getting at least one book, B is getting at least one book, as well as A, B and C, they are getting the books which are different. Books are different as well as persons are different. That is a condition in this case. See, if suppose there is no condition. Sorry, this is 60. Yes. Thank you so much, Shivam and Sahid. Okay, this is a condition. A should be greater than equal to 1. B should be greater than equal to 1. See, if there is no condition, we have 6 different books and we want to distribute these books into 3 persons. In how many ways can this be done? This is 3 raised to power 6. Why so? Because for first book, we have 3 choices. We can give it to A, we can give it to B, we can give it to C. Similarly for second book, similarly for third book and so on. So how many choices are there? 3 raised to power 6. But this include those cases in which A is getting 0 books, B is getting 0 books and both are getting 0 books. So we want to subtract those cases. Now, if A is getting 0 books, it means B and C, they together are getting 6 books. Now, it can be done in how many ways? 2 raised to power 6. With the same thing, for first book, there are 2 choices, B and C. For second book, there are 2 choices, B and C, and so on. Now, I am taking that case in which B is getting 0 book. Now, in this case, A and 6, they are getting 6 books. Again, there are 2 raised to power 6 choices with the same logic, but it includes those cases as well in which A is getting 0 book, B is getting 0 book and C is getting all 6 books. So this case is included in both these cases. So what is the answer? It will be 3 raised to power 6 minus, we are subtracting the rejection part, 2 raised to power 6 plus 2 raised to power 6. We are subtracting this case. Why so? Because this case is included in both these cases. That's why. So this is the answer in this case. What is 3 raised to power 6? That is 729 minus what is 2 raised to power 6? 64 plus 64 minus 1. So it will be 127. 729 minus 127. This is the answer in this case. If we go by selection way, I mean positive way, I mean if we count all these possible cases, there will be numerous cases. Whenever you are getting more cases, it's better you go by rejection thing. What is rejection thing? Total minus the reverse part. Yeah, any problem in this now? Yeah, all of you? Okay, good. Now I'm coming to question number 35. Very, very good question. See, it should be distinct, not district. It should be distinct. Yeah, any problem in this question? Okay. The number of 6-digit numbers of the form AB, 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 each of which is a product of exactly 6 distinct primes is. Yes. First of all, my number is AB, AB, AB. I think this is manageable for you. This number can be written as AB into 10101. Now, this 101 can be written as 3 into 7 into 13 into 37. These are 4 distinct primes. What was my question? It says we need 6 distinct primes. It means AB should be a number which contain this format P into Q, where P and Q are distinct primes. Is it okay with you till the moment? Where P and Q should be distinct primes. Okay. Now, we need a 2-digit number which can be broken into 2 primes, P into Q. What was the earlier prime factorization? It was AB into 3 into 7 into 13 into 37. Since we need distinct primes, we cannot use 3, 7, 13 and 37 because we are using them already. Are you getting me, guys? Okay, so I'm starting with 2. With 2, we cannot use, once again I'm writing, we cannot use 3, 7, 13 and 37. We cannot use them. Now, with the 2, it can be 2 into 5. It can be 2 into 7. We cannot consider this. So, we'll take 11. I cannot use 13. We'll take 11, 13, 17. We can take 19. We can take 23. We can take 29. We can take 31. We cannot take 37. We can take 41. We can take 43. We can take 47. So with 2, these many cases are possible. And they are 11 in this case. 11 they are. These many cases are possible. I'm not considering this. That's why we are left with 10 cases. With 2, there are 10 cases possible. Now, with 3, we cannot use. With 5, again I'm writing, we cannot use 3, 7, 13 and 37. We cannot use them. So with 5, 5 into 11, 5 into 17 we can write, and 5 into 20 we cannot take, of course, but that is the limit because we need 2-digit number. If I take 5 into 23, it will be a 3-digit number. What was my requirement? It was a 2-digit number when broken into 2 parts. Those 2 parts should be prime always. That's why we are left with these many cases. So these many cases are possible. I cannot use 7. I cannot use 11 as well, because if I take 11 into 13, 13 I cannot use. If I take 11 into 17, that is not a possible case. Again, I'm getting 3-digit number. So these many cases are possible, but we have to reject these 2 cases. We will reject these two cases because my format was AB, AB and AB. This was the format, but in this case we are getting all digits same. That's why we will not consider these two cases. We are left with remaining cases. Now you can count those cases and you can mark the answer. Are you getting me, all of you? Yes? I'm waiting for your response. Aman, no, this is not 19. You have to count those cases. Why 5 into 19? Okay, I have to consider that as well. Okay, got it. 5 into 19 as well. We will count because 5 into 19 is 95. That is less than 100. Thank you so much. Yes, we'll consider that. And we'll subtract these two cases. Okay, still any problem in this? Should I proceed further? Now, question number 37. It was data sufficiency. Yeah, any problem in this? Whenever you face any problem in any of the question, please write question number in the chat box. 37. Please write 37 in chat box. Since I'm getting no response, I'm moving to next question. Yeah, 38. Yeah, any problem in this? question. I'm moving further. 38. Okay, Monica. See, can we measure 15 minutes using two given sunglasses? It's a very frequent question. You can see this question in many papers. See, this is 7 and this is 11. Best way to do this question, I'm not going into logic. Best way to do this question is by using equation. See, we want to measure 15 minutes and we have two options. Either we can use 7-minute glass or 11-minute glass. Suppose 7-minute glass is I'm using this glass x times and I'm using 11-minute sand glass y times. So what should be the equation? It should be 7x plus 11y. It should be 15. What is the solution to this equation? This is 2, 1. It means for 11-minute sand glass, we'll use it twice. In 7-minute sand glass, we'll use it once. Since I'm getting a solution, that's why this is possible to calculate 15 minutes. Now I'm taking B statement. It says 4x plus 10y is equal to 15. Obviously, solution to this problem is not possible. Why so? Because 2 will come out 4x plus 10y, and 2 is not dividing 15. 2 into something can never be 15. That's why solution to this problem is not possible. Now, for A, we are getting a solution. That's why we can measure 15 minutes. For B, we can say solution to this problem is not possible. That's why we cannot measure 15 minutes by using 4 minutes glass and 10 minutes sand glass. That's why we can answer this question by using either statement alone. That was one way. Now another way. See, we have 7-minute sand glass, 11 minutes sand glass, and we want to measure 15 minutes. So what can be the technique? If we start the two timers together, when the 7-minute timer run out, first of all, We'll start both the sand glasses together. When 7 minutes sand glass runs out, we'll reverse it. Now 7 minutes are gone. In 11 minutes sand glass, sand of 4 minutes is left. We'll wait for that. 4 minutes are gone. It means 11 minutes are gone and 7 minute sand glass. In this 4 minute sand will be there. We'll reverse it again to measure 4 more minutes. So we can consider more 4 minutes. So it will be 15 minutes. Is it okay with you, all of you? Yes? Okay. Yeah, 39th question. I'll consider this question as medium. Yeah, any problem? 39 Sahith. Okay. See, what are the equations? What is my first equation? This is u. If I put 1 by x as u, 1 by y as v, and 1 by z as w, I am getting u plus 2v plus 4w is greater than 17. That is my first equation. What is my second equation? This is 3u minus 2v minus 2w is greater than 9. These two conditions are given and we want to calculate it for this is 9u minus 14v minus 20w greater than minus 14, I think. This is my first equation. This is my second equation. By using these two statements, I want to answer whether this is true or not. First of all, see, this is data sufficiency. Whenever you have a question of data sufficiency, always take individual statements first of all. I'm taking statement first. By using statement first, I cannot answer this question because there can be numerous values of u, v and w for which my required statement can be true, cannot be true. I cannot say anything by statement 1 alone. Similarly, by using statement 2 alone, I cannot say anything. But if we club these two statements, if we multiply, see, I need this combination. If we multiply this by 3 and this by 4 and subtract first from second, I am getting 9u. This is minus 8 minus 6, 14v minus 8 minus 12. If we solve this, we'll get this is greater than minus 15. If this is greater than minus 15, it can be minus 14 as well. It can be more than minus 14 as well. See, minus 14 is greater than minus 15. That's why we cannot be sure whether this expression will be more than minus 14. It can be minus 14 as well, because my combination says that this expression, this star expression, that was the required expression, the star expression is more than 15, minus 15, sorry, and we want to check it for minus 14. So we cannot be sure whether this will be greater than minus 14. That's why we cannot answer this question by using even two statements together. Yeah, any problem in this question now? Good one, algebra. Okay, let us move. Here, question number 40th. Not an easy question. Question number 40th. Please write question number in the chat box. This is A, B, C, D is a square, P is a point such that DP is to PC is 1:2, and let it be BQ. This is a perpendicular, and we want to know the ratio of the area BQPC divided by the complete thing. See, whenever ratio and percentage is asked, I'll take as it is data. I'm considering DC as 3. You can take anything, x, 2x, whatever, but it will give you the same answer because this is a question of ratio. So I'm considering the square length B, let it be 3, DP is 1, PC is 2, and we want to calculate the area for PCDQ. That is a required thing in our expression. Now PCBQ is a 4-sided figure. We are not sure about the shape of this. We don't have any formula for this. So it's better if you calculate its area as is equal to its area, total area minus triangle DPA area minus triangle BQA area. We will subtract these two areas. First of all, DPA. We can apply the formula half into base into height. So what is DPA area? Half into base into height. As you can see in the figure, it will be 3/2. This is 3/2. Now what is the thing left? We want to calculate what area? ABQ area. I want to use this figure. Now I'm joining these two lines. Once again, I'm taking the figure. I'm joining this line. Its area was 3/2. It was a 90-degree angle. We want to calculate the area of this. The names were A, B, C, D, P, and this was Q. We were considering this as 3, this was 1, this was 2. This is again 3. Now, first of all, we can calculate AP. AP will be nothing but 3 square plus 1 square, that is √10. I'm using Pythagoras here. We have calculated AP. And we want to calculate ABQ's area. Are you getting me, guys? There are some technical glitches actually. That's why I'm going at a very slow pace. AP is √10. Are you getting me, all of you? Okay. What is the triangle APD area? This will be 3/2. What will be the BCP area? Now I'm taking triangle BCP. BCP is nothing but again the same formula, half into base into height. Half into 2 into 3. That is 3. Similarly, triangle ABP area. ABP will be left with 9, I mean the total area, minus these two triangles, 3/2 and 3. So we are left with 9/2. Is it okay with you? So what will be ABP's area? It will be 9/2. Okay. Now I'm using the formula again. If we calculate the area of ABP by using half into base into height, we can write half into BQ into AP. We know the length of AP, this is root 10, and area we know now, this will be 9 by 2. So by using BQ, this formula, we'll calculate BQ, and I'm getting BQ as 9 by root 10. BQ is 9 by root 10. Is it okay? Now we know the length of BQ and we know the length of AB as well. By using this, we can calculate AQ by using Pythagoras. So if I need Pythagoras, I'm using Pythagoras, it will be AQ is equal to 3 square minus BQ's length. So we are able to calculate AQ, which comes out to be 3 by root 10. Now this becomes easy. Now we can calculate the area for BQPC quadrilateral. How come? We'll calculate the square area, which comes out to be 9 in this case. From 9 we'll subtract APD's area and BQA's area. APD we have calculated 3 by 2. BQA we can calculate now. What is BQA? It will be half into base into height. I mean half into BQ into QA. We know BQ as well as AQ. What is half into base into height? I mean BQ into AQ. It will be half into 9 by root 10 into 3 by root 10. That is the AQB's area. Now I think this is manageable. Geometry questions are very difficult to explain actually. It's a small page to explain. Now come to next question. Yeah, it was a calculative set, and the main part was there are only 2 questions. Yeah, any problem in this? 49th and 50, there were 2 questions. Yeah, any problem in this? Please write question number in the chat box. Monica, I'll give you extra 5 minutes after the session. Let me explain all the difficult questions first of all. Yeah, in these 2 questions, 49th and 50. 49. Given that the sigma for all typists is an integer, for how many of mentioned typists it is not possible to calculate the exact value of sigma. What was sigma's definition? The sigma of a typist is the average of the 2 middle quantities. If the number of lines typed by him, this and this. See, what is sigma? Sigma is average of the 2 middle quantities. Aman, you got the set first of all? You tell me. For day 1, for example, Gaurav is typing 23% of the lines. Sanjay is typing 24% of the lines. Salim is typing 14% of the lines. And Amar is typing 20% of the lines. It means what? Gaurav, Sanjay, Salim and Amar. In total, they are typing 81% of the lines. They together are typing 81% of the lines. It means remaining 19% are typed by other 2 typists. And this 19% is nothing but 76. If 19% is 76, it means what was the total line? They were 400. Okay, now it means Gaurav is typing 23 into 4, 92 lines. Sanjay is typing 24 into 4, 96 lines. Salim is typing 14 into 4, 56 lines. And 20 into 4, that is 80. Are you getting me, Aman? Now I'm making a table. By using the same thing, I can write there were 6 typists: Sanjay, Salim, Gaurav, Amar, Kandar, Kapil and Deepak. By using the same technique, we can write the number of lines by them day wise. For example, for day 1, Sanjay will be 96. I'm copying the data actually. 56, 92, 80, 0 to 55. And for Kapil it will be 0 to 55. For Deepak it will be 0 to 55. For day 2 similarly, it will be 0 to 55, 70, 0 to 55. For Amar this is 0 to 55, 63, 56 and 91. Similarly for day 2 you can write, day 3 I mean. For day 3 if I write, it will be 54, 42, 48, 0 to 41, 0 to 41, 54 and 0 to 41. Similarly for day 4 I'll write, for day 4 this is 99, 0 to 45, 0 to 45, 81, 63, 0 to 45 and 162. That was the data we can compile by using these 4 days typing thing. Now see, what was sigma? Sigma was average of the 2 middle quantities. What do you mean by middle quantities? You leave maximum and minimum value. For example, for Sanjay I am counting this. For Sanjay, what is the maximum thing? For Sanjay this is maximum. And what is the minimum thing? See, we are getting 54 as well as 0 to 55. At day 2, he can get anything from 0 to 55. If he is getting 0 to 54, what will be the minimum thing in this case? 0 to 54 only. If he is getting 55 lines on day 2, what will be the minimum thing then? 0 to 54. So maximum will be 99 and minimum will be 0 to 54. Are you comfortable in this? All of you? Yes, Aman? 0 to 54, that will be the minimum thing. Okay? If 0 to 54 is the minimum thing, we are left with 2 middle quantities and they are 96 as well as 54 to 55. Is it okay with you? All of you? Yes. Now I am writing only 2 middle quantities for all these typists. For Salim it will be 42 to 45 and 56. 42 to 45 and 56. For Gaurav, it will be 48 and it will be 0 to 45. 0 to 45 and 48. These will be 2 middle quantities for Gaurav. Yeah, any problem till the moment, Gaurav? Aman? Now, for Aman, once again we'll count. the two middle quantities. For Amar, the two middle quantities will be 80 the two quantities will be 80 and 0 to it will be 0 to 55. 0 to 55, because in these 2 days, day 2 and day 3, we have range. That's why we'll consider the whole range 0 to 55. By applying the same logic, we can calculate two middle quantities for each of the typists. Now, what was the question? For how many typists is it possible to calculate a single value of sigma? This is possible for Sanjay only. Why so? See, these are the two middle quantities 96, 54 and 55. This is also mentioned in the question that sigma is an integer. 96, one value is fixed. Other value can be 54 as well as 55. But if we take 55 and if we calculate the average is nothing but sum of two quantities divided by number of observation, that is 2 in this case. So it will be 96 plus 54 by 2, or either it will be 96 plus 54 by 2, or it will be 96 plus 55 by 2. But we cannot take case of 55 because in that case sigma will be not an integral value. We have to reject that. So for Sanjay it can be calculated exactly. For other typists we have many things. For example, Salim, if we take one middle quantity is fixed 56. Now other quantity is 42 to 45. We can take any number from 42 to 45. If we take 42 as well as 44, we'll getting two sigma's values. Both of them are integers. For Salim, we are not able to get exact one value. For similarly, for Gaurav, for Amar and remaining of the typists, we cannot calculate the exact value of sigma. That's why, what is the answer for this? This will be except Sanjay, all the remaining typists. For all the remaining typists, this is not possible to calculate the value of sigma if sigma is an integral value. Is it okay, Aman? Now 50th, that was the same question. Yeah, 57 to 58. (57, 58). It was a good set, good one, good logic. Yeah, any problem in these two questions in this set? Please write question number in the chat box. Okay. I have to make a table in this case. First of all, see. First of all, I am explaining the logic. See, in case 1992 in class 6th, there are 84 students. It means these 84 students are those who are coming from class 5th and they are promoted to class 6th in 1992. It means in 1991, in class 5th, there were 102 students. From these 102 students, 84 are promoted to class 6th and remaining are failed. What is remaining thing? This is 102 minus 84, that is 18. It means in 1991, there were 102 students in class 5th. 84 are passed, that's why they are promoted to class 6th in 1992, and remaining 18 are failed. If remaining 18 are failed, they will continue in class 5th in year 1992 only. Are you getting me? But in class 5th, there were 96 students in 1992. In the last year, 1992, there were 96 students. And 18 students are the same students who were present in class 5th in 1991, in the last year, I mean. So, how many new students? 96 minus 18. What is 96 minus 18? 78. It means there were 78 students, 78 new students in class 5th in year 1992. And these 78 students are those students who have passed class 4th in 1991. Are you okay with this logic? By using this logic, we'll make a graph, we'll make a table. Okay, see what is the thing then? I need to use a new page. See, class 1, 2, 3, 4 and 5. First of all, I'm taking this year 1990. I'm writing pass and fail, pass and fail. Similarly, for 1991, we'll write pass and fail. See, applying the same logic, in class 5th, 84 students were passed, remaining 18 were failed, 78 were passed, 26 were failed. These 26 students, and suppose I'm taking the passing candidate in 1991 in 4th class, they were 78. These 78 students were those students who were in 3rd class. So by using the same thing, I can write 74, 26, 80, this will be 86 with the same logic, then 18, then we have 88, 26. By using the same technique, is this okay, Abhishek? And Shivam as well? Okay, now I'm taking the data for 1991 and I'm writing the pass-fail candidates for 1990. They'll be, bottom will start with 90 and 6, 96 and 14, 90 and 22, 78 and 8, then we have 96 and 60. Now, question 2, your question was question number 56. What was the question? It says, what is the difference in the number of students who joined the school in the year 1991 and those who joined the school in the year 1992? Okay, 1991 and 1992. First of all, we are counting the new joinees for class 1 in 1991 and 1992. In 1990, I'm coming to, I need this data actually for 1st class. Yeah. In 1990, there were 112 students. They were the new joinees. 16 are failed. By the table we can see. If 16 are failed, 16 shifted to class 1 in 1991. 16 are, from these 112, 16 are failed. These 16 are the same students who will continue in class 1 in 1991. I'm subtracting 16 from this. 114 minus 16. So there are 98 new joinees in 1991. 98 new joinees, new students. Similarly, in 1991, by using the table again, 26 students are failed. From these 114, 26 students are failed. These 26 students are they will remain in the same class. I'm in class first in 1992. That's why I'm subtracting 26 from this. I'm getting the same answer. What is asked? Difference of these two quantities, that is 0 in this case. Yeah, any problem in this question now? Shivam and Abhishek. Okay, let us move. Yeah, 86 question. '87th. Yeah, 14th. Any problem in 14th question? Or 20th? Please write question number in the chat box. 23rd or 31st? '23rd. Two squares are chosen at random from the small squares drawn on a chessboard. What is the chance that the two squares chosen have exactly one corner in common? In many papers you can see this type of question. Sometimes it says one corner in common. Sometimes it says one edge in common. There can be numerous questions. Now, suppose this is my chessboard. See, this is my chessboard. I'm taking an example. Now I'm choosing two squares. What is probability formula? Probability is number of favorable cases divided by number of total cases. In 8 by 8 chessboard, how many squares are there? There are 64. So I'm writing 64 in the base. C2 I'm writing because we are choosing any two squares out of those 64. That is the total number of cases. Now I'm writing number of favorable cases. See, we are choosing two squares and we want exactly one vertex common. Now first of all I'm choosing one square. For example, I'm choosing corner square. I'm choosing this square and we want exactly one corner common. So what can be the permissible choice? This. So for these there are 4 corners and 4 corner squares. For these 4 corner squares there is exactly one choice. So I'm writing 4 here. I mean 4C1 into 1C1 plus. Now I'm taking edge square. For example, I'm taking this square, the pink one, and we want one corner common. So these many choices are available. For one edge square, 2 squares can be chosen. How many edge squares are there which are not corner squares? On every edge, on every side of the square, we have 8 squares. Out of these 8, 2 are corner squares. So we are subtracting these 2. We are left with 6 squares. At every edge, at every side of the square, we have 6 edge square. We call it edge square. We call it side square. So in total there are 24 because there are 4 sides. So I'm writing 24C1. I mean 24 into 2C1. I mean 2. Because for every square there are 2 choices. Plus, now we are left with interior squares. In total, how many interior squares are there? Can you say there are 36? You can subtract 24 plus 4 from 64. As well as you can do one thing. you remove the outer boundary, you will be left with a 6 by 6 square. That will be nothing but 36 squares. 36 into, for example, I am taking this square, that is the interior one. For this, these many choices are possible. That's why I'm writing 4. 36 into 4. Now, this is not the exact answer. We have to divide this whole thing, divide this numerator by 2. See why so? Since I'm getting repeated cases. See, when I was counting 8 square, I was getting this combination, this pink one, dark pink. And when I was counting interior square, I was counting the same combination, this bold pink. That's why I'm taking all the cases but twice. That's why to balance this, I'm dividing it by 2. So this is the answer. Is it okay, all of you? Yes, all of you? Okay. Yeah, 20th. Yes, yes, Shivam. Once again. Let me make it once again. Yes, Shivam. See, suppose I'm counting corner square. I'm getting this combination. That is counted. When I was counted the interior square, I was getting the same combination. See, this is the interior square. And we are considering the 4 corner square, corner sharing. I'm getting the same combination. So I'm getting every combination twice. That's why. Is it okay? Okay. Okay, Shivam. Okay, any problem in question number 20th? Okay. Yes, Monica. Now your question. Please tell me your question number. Yes, Monica. Please tell me your question number. It was a very easy question. It says MTNL has a waiting list of 5,005 applicants for its recently launched mobile phone scheme. The list shows that there are at least 5 males between any 2 females, the largest possible number of females in the waiting list. We want to maximize the number of females. That's why I'm starting the waiting list with a female. My target is to maximize the female. Now, it says there are at least 5 males between any 2 females. If we want to maximize the number of females, we have to minimize the number of males. But the condition 2, that should be followed. There are at least 5 males between any 2 females. That's why I'm considering exactly 5 males. Then a female. Again 5 males. Then a female. And so on. It means I'm getting a block of 6 in which there are 5 males and a female. How many candidates were there? 5,005. I'm dividing it by 6. It comes out to be 834. It means there are 834 blocks in which there is exactly 1 female and 5 males. Now we want to calculate the number of females. It means there are 834 females, but we are getting a remainder of 1 in this case. That will be the last candidate. in the list. That should be a female again, because we want to maximize the number of female. That's why what is the answer? 835. Is it okay, Monica? Okay, question number 33rd now. Before explaining this question, let me take one more example of this kind. This is known as AGP series, arithmogeometric series, combination of these two. I'm taking anything, suppose, let it be, we want to calculate, say this, 4 by 19, 44 by 19 square, 444 by 19 cube, so on up to infinity. Suppose we want to calculate this. See, this is known as AGP series. You can apply the method we will discuss now, but you have to check one thing. In denominator there should be a GP always, and in numerator there should be a pattern. This pattern can be anything. It can be AP, it can be this kind of thing, 444, 444, etc. Now what is the technique? Multiply the complete series with the common ratio. What is the common ratio in this case? It will be 1 by 19. Because there is a GP in denominator, that's why what is the common ratio here? That is 1 by 19. I'm multiplying the complete series by 1 by 19. Now at first term, I'll get 4 by 19 square. What is my target? My aim is to match the denominator. I'm leaving the first space. Then I'm writing. Now subtract these two. We'll get 18 by 19s. First term as it is. Second term is 40 by 19 square. Third term is 400 by 19 cube, and so on up to. Now it will be a perfect GP with a common ratio of 10 by 19, and there are infinitely many terms. That's why you can apply that A upon 1 minus R formula. Is it okay with you, Abhishek? First of all, I have explained the concept. Then I'll come to the question if you are okay with this. Okay. Now, see, we want to apply the shortcut. You know the method now. We will not write the whole thing. We'll write it in shortcut thing. See, first of all, what was the process? We multiplied the whole series by common ratio, that is 1 by 19. Then we subtracted it. If you subtract, suppose x, if you subtract 1 by 19 of anything from itself, you are getting 18 by 19. If you are subtracting 1 by 19 of anything from itself, you will get 18 by 19 of that thing. Now the first term as it is, same denominators. Now what was the second term? 44 minus 40. What was the third term? 444 minus 44. That was the thing. I don't want to write this stuff. If you know the procedure, you can write it directly. Now come to the question. What was your question? It says 1 by 8 plus 3 by 8 square plus 6 by 8 cube, 10 by 8 raised to power 4, and so on. I'll apply the same thing now. What is the common ratio here? 1 by 8. We'll subtract 1 by 8 of s from s. I'm writing it directly. You can write the whole thing. 7 by 8s. Then I'll write the first term as it is. Then 3 minus 1 is 2 by 8 square. Same denominator. 6 minus 3, 3 by 8 cube. 10 minus 6, 4 by 8 raised to power 4, and so on up to. Now there is no formula to write the sum of infinitely many terms of this series, because that is not a complete GP. We'll apply the same process once again. Again, from 7 by 8 of s, it's 1/8 is subtracted. Again, I'm writing the same procedure. If you subtract 1 by 8 of anything from itself, you will get 7 by 8. Now the first term as it is, 2 minus 1 is 1 upon 8 square. 3 minus 2 is 1 upon 8 cube, and so on up to. Now you can apply that formula a upon 1 minus r. A is 1 by 8 here, 1 minus r. You will get 1 by 7. I think that is okay with you. So what is S value? It will be 64 upon 343. Yeah, Abhishek, is it okay now? Okay, any other question? Now 24th question Shivam has asked. Shivam, I think that was easy. 24th. That was an easy question. Now question number 41st, Abhishek. Okay. Okay, 41st question now. It says f of x plus half f of 1 minus x is equal to 1. And we want to calculate the value for twice of f of 0 plus thrice of f of 1. It means we want to calculate the value of f of 0 as well as f of 1. If we take x as 0, we'll get f of 0 plus half f of 1 is equal to 1. If we take x as 1, we'll get f of 1 plus 3 by 2 f of 0. Since I'm getting two equations in these two variables, we can say we have two equations in f of 0 and f of 1. We can solve it and we'll get the value of f of 0 as well as f of 1. Now we can put the values. I think that is easy now. Abhishek, you got that? Okay. I think now it's okay. That is done. Okay, thank you so much.